more with prime factors. If I want to look for prime factors of a number, the quickest way to do that is with a factor tree. So we'll do it on a few different numbers. With a factor tree, we're looking for prime factors, so we pretty much try to stick with working with primes as much as possible, but you can deviate a little bit, and we'll look at an example. So let's start with 12. We played with that number already. And the first prime number is 2. 2 definitely goes into 12 6 times. And so here I'm starting branching out downward. It's usually tradition to branch down, but you can branch in any direction you want. Now 2 as a prime number doesn't break down any further, but 6 is not prime, it does. And I can use 2 again, so I will. 2 goes into 6 3 times. So usually if there is a 2 as a factor, and again, I just keep using 2 as often as possible. So the ends of the tree show me the prime factors of the number. And so I can say that 12 is equal to 2 times 2 times 3. This right here is called a prime factorization. I factored the number, and I'm only using primes to do it. If I were to say, I could say that 12 is equal to 3 times 4, for example. This is just a factorization, but not prime, because 4 is not prime. Okay, so this is a factorization, but it's not a prime factorization because 4 isn't prime. When you make your tree, somebody might have looked at 12 and thought, hey, 12 is 3 times 4. Why not? Sure, that's fine. 3 is prime, you can't break it down anymore, but 4 you can as 2 times 2. So somebody else might say, well, no, 12 is really equal to 3 times 2 times 2. Well, it doesn't really matter which order you multiply in. This is exactly the same as that right there. So as far as prime factorizations of a number goes, there's really only one way to do it if you put the numbers in order. So I pretty much get the same answer regardless of how I build my tree. Let's try another. How about 36? We looked at that one earlier. And I want to find the prime factorization. And so again, the easiest thing in my opinion is to take 2 into the number, and 2 goes into 36 18 times. And if 2 keeps working, keep doing it till you can't. 2 goes into 18 9 times. Okay, odds 9 is odd, I'm done with that. So then 3 goes into 9 3 times, and I'm done. The prime factorization of 36 would be 2 times 2 times 3 times 3. And sometimes we'll abbreviate it with exponents. So I could also state this as 2 squared times 3 squared. And again, that's a prime factorization. I'm not finding all the factors, I'm only focusing on the prime ones. Questions?